The grow your own food movement is gaining momentum worldwide as people like us are taking more control over what we eat. Our journey to self-sufficiency led us to a rural property away from the city we lived in for decades. Food prices in our region regularly increase, especially during winter months when most fresh produce is imported. Unfortunately, food choices are often limited, and finding nutritional, organically grown produce isn't always possible in many parts of the world. We live in a cold climate, Zone 3, in Northwestern Ontario, and our growing season is less than 100 days. We really don't have much time to grow a wide variety of produce, so we rely on row covers, low tunnels, high tunnels, and greenhouses to extend the growing season in the spring and autumn. Having a greenhouse to grow our own food is part of our sustainability and food security plan. We hope that this DIY plan will inspire you to build your own. Thank you for your support. The entire frame for the modular greenhouse will be made from standard 3/4-inch steel rebar, readily available from most steel suppliers or construction wholesalers. This size of rebar is also called number 6, a common size in the construction industry. This diameter of rebar bends well and will create a strong frame that can handle heavy snow loads for the size of frame shown in this plan. If you live in an area that will receive little or no snow and is fairly protected from the wind, you could use 1/2-inch rebar instead. However, be aware that a greenhouse frame of this size made from 1/2-inch rebar will likely not handle a heavy wet snowfall. If you want to make a larger or taller greenhouse frame, you can use larger diameter rebar. However, you will need to do some testing to determine the strength of a loop by making one and then pulling down on the center to determine how much weight it can hold. I have done this type of destructive testing on the frame size shown here. Using the 3/4-inch rebar, I can hang from the bars without bending them. I only own the most basic tools, including a hardware store AC welder, an angle grinder, a hand drill, and typical hand tools. Projects on the chopzone.com website were built using only basic tools. Since I don't have the luxury of an indoor workspace, I also do my projects outdoors. I want to emphasize that you can build practically anything with basic tools and parts, as long as you enjoy putting in a good day of hard work. Please don't think that welding is a difficult skill to learn, because it isn't, especially when working with basic steel, such as the rebar used in this project. If this is your first time attempting to weld or build something, please have a look at the DIY tutorials on our forum, including the basic welding tutorial. Once you have the ability to weld metal together, an entire world of do-it-yourself power will be in your hands. I use an angle grinder for all of my cutting and shaping of metal components. This inexpensive tool is highly versatile. It can cut, shape, and clean up metal in a hurry. Shown here is a disc called a zip disc or cutoff disc. It's a thin grinder disc used to quickly cut through metal. What would normally take 5 minutes using a hacksaw can be done in 5 seconds using the angle grinder. You can choose to cut all of the rebar using a hacksaw, but be aware that there will be many cuts made. So consider an angle grinder if you do not have one in your DIY toolbox already. An angle grinder, like any high-speed tool, needs to be handled with safety in mind. So wear work gloves, a full face shield, and ear protection, just as you normally do while using a skill saw. In these photos, the safety guard is removed from my angle grinder so you can see the work area clearly. I recommend keeping the safety guard in place as per the manufacturer's instructions. In the next few steps, I will show you how to do a welding strength test on your rebar. It's a great exercise if you are new to welding and want to fine-tune your skills before committing to welding the entire frame. Rebar is a fairly easy steel to weld since it is solid bar. When welding two pieces of metal together, you are filling the joint with weld metal from a welding rod. To make a proper joint, grind out some of the original rebar as shown in the picture here. The resulting angular removal of material leaves what is called a chamfer. This gap will eventually be filled in again with the weld metal from welding rods. To make welding chamfer, grind away the end of the rebar as if you are sharpening a pencil. Size and angle are not critical, just something in the 45-degree zone, and about 1/4 inch of removal will do. I am using a coarse grinder disc for this work, which is the heaviest of the grinder discs, made for shaping and grinding steel. This is the optimal chamfer for the proper welding of rebar. It takes about 30 seconds to prepare the rebar using the coarse grinding disc, ensuring that the entire joint is filled with weld metal. As you learn, feel free to try making a weld without first preparing the chamfer and then doing the hammer test shown in the next few steps. You will likely find that the non-chamfered welded part will be easy to break, since the weld will only be applied around the very outer edge of the joint. To do a few practice runs for testing, cut a few pieces of 10 inches long rebar, and then prepare the end of your rebar as shown here for welding. This is the basic T-joint required for most of this project. Once the two pieces are set in place, tack weld the top of the joint as shown here. You will notice that each time you weld, the pieces move slightly right after they cool. This is called welding distortion. It occurs because the welded metal contracts slightly as it cools off. When welding a project that might require precision, welding distortion is the enemy. But as you become a better welder, you will learn to think ahead and mitigate this problem by setting up the welded pieces to account for the contraction. In this project, don't worry too much about the slight welding distortion because this project doesn't require high precision. Once you have the initial tack weld completed, flip over the part and weld the other side, completing as much of the joint as you can. You may be able to get around the entire joint if there is nothing in your way, but sometimes you will need to start and stop 3 or 4 times to weld completely around the joint. Each time you start and stop, try to move to the opposite side of the joint, as this action will counter some of the welding distortion by balancing the forces on each side. The welded joint shown here isn't too bad, although it could probably use one more complete pass to build up the welded area a bit more. Again, nothing about this project is considered high precision, so as long as the welds pass the hammer test as shown next, you will be fine. To test the strength of the weld, place one of the rebar pieces in a vise as shown here so that you can smash away on the horizontal 90-degree welded bar. If you are new to this hobby, you should expect a few failures as you tune your skills. One of the more common reasons for a failure is often not using enough heat when you weld, so try cranking up your amps next time if your weld breaks. I am using my basic department store AC welder on the 100 amp setting, welding only with 6013 rod with a 3/32 inch diameter. I use that rod for everything I do, from 2-inch thick steel right down to the thinnest of bicycle tubing. Every bike, trike, and vehicle shown on the chopzone.com website was welded by this inexpensive AC welder. Looks like I passed the bend test. Pound the rebar until something bends as shown here. If the weld does not have enough penetration, then the pieces will likely break apart before the rebar bends. Don't expect to pass the first bend test if this is your very first attempt at welding. If the weld cracks, look at the joint and try to determine why. Often, a new welder will simply weld too cold, resulting in weld metal that looks like bubblegum instead of fused metal. Crank up the heat and spend a few days learning to control your movements. You will soon be welding strong, reliable joints. It's okay if the weld isn't exactly pretty, as long as you pass the bend test. If you want to clean up the weld, then that's another great task for the heavy grinder disc. The modular greenhouse frame is made from multiple egg-shaped half-circle ribs, joined together to form an extremely strong shape designed for covering with a tarp. These hoop houses are ideal greenhouse frames since they are extremely strong, easy to make, and do not have sharp corners that would damage a tarp. Square greenhouse frames made of wood are hard on tarps due to sharp corners that continually rub on the tarp, but in our design there are no such problems. Wood frame greenhouses are also prone to damage from snow loading or wind events. You are now at the point of the build where you need to determine the width and height for the greenhouse frame. This is completely up to you. If you just want to build a replica of the greenhouse shown here, then use the measurements shown throughout this plan. A loop roughly 118 inches wide with a height of 92 inches. Do it yourself is all about experimentation and building to suit your own requirements, so feel free to change any dimension. You may prefer a wider greenhouse if you live in a no-snow zone, or a taller structure for a tree nursery. While experimenting with different hoop sizes, use a piece of flexible PVC so you can bend it into a loop and actually see the height and width. I chose this size of hoop because it's tall enough to walk around inside and wide enough for two raised beds and a middle path to maneuver a wheelbarrow. Plus, we need a durable in our heavy Northwestern Ontario snow zone. An egg shape is strong for snow loading. Shown in this photo are the 2x4s that will be used to make a hoop bending jig. Once you have chosen a size to make each hoop, width and height, you will need a jig that is about 6 inches longer than the rebar. I did not have a 2x4 that long, so I just fastened two together. The bending jig is basically a board with holes drilled at each end so that you can form a loop of the desired width and height from the straight rebar length. Whatever width you choose to make the loops, ensure the bending jig is a slightly larger so you have room to drill the holes. Since I did not have 2x4s that were long enough, I had to use deck screws to join two of them together as shown here. My greenhouse ribs are made from 24-foot-long rebar segments, resulting in a hoop that will be 118 inches wide by 92 inches tall. To make the bending jig, holes are drilled through the wood at the desired width. The marked line shown on the 2x4 in this photo is 118 inches from the line at the other end. Now, when I bend the 24-foot-long rebar into a loop, the total width of the loop will be 118 inches. The reason I chose this width was because it offers plenty of height, as well as a decent width for both raised beds and a middle walking path. The holes you need to drill in the bending jig should be slightly larger than the diameter of your rebar so that it can easily fit into the hole. My rebar is 3/4 inch in diameter, so I drilled 1-inch holes through the wood. Since you will be welding the rebar when it is sitting in the bending jig, you want the holes to be large enough to easily release the rebar from the jig once the welded part cools. The distance between the two lines drawn on my jig is 118 inches. This is the length of the floor bars. The floor bars hold the shape of the hoop and support the raised beds. These horizontal bars also determine the width of each hoop. Without the floor bars, the hoops would spring back to their straight shape once released from the bending jig. Some smaller greenhouses or grow tunnels are made by simply jamming the bent hoops into the ground in hopes that they will maintain their shape. That type of construction is better suited for smaller, temporary structures. Bending the rebar is not difficult, but does take some careful maneuvering since it will want to spring back at you. Consider this when you are bending the ribs, making sure that your helper is not standing in the line of fire at the one end of the bending jig. If the rebar slips from the far end of the jig while you are bending the loop, it will come flying out with enough force to be dangerous to anyone or anything nearby. To begin the bending process, place one end of the rebar into a hole in the jig as shown here. The rebar should be placed into the hole so that a few inches are protruding out the other end of the jig into the ground. A pair of vice grips is used to secure the rebar on the underside of the jig. The vice grips prevent the rebar from slipping out of the hole as you bend the loop all the way around to the other side of the bending jig. Don't try to bend the loop without first securing the end of the rebar, as it may come flying out of the jig with a good amount of force. With one end of the rebar in the bending jig secured in place by the vice grips, slowly walk the other end over to the far hole and place it into the jig. Hold the rebar by the end so that the loop that forms is as uniform as possible. Let the rebar form its own loop rather than trying to force it. As you walk the rebar over to the other hole, it will naturally bend into an egg shape. There will be slight variations in the completed loops, but not enough to make an overall difference in the final greenhouse frame. The completed rib will bend into an egg-shaped loop as shown here. If you are making a wider greenhouse because you have little or no snow, then the loop will be more of a circular shape. Feel free to experiment with various widths and lengths, keeping in mind that if you try to make a loop that is much taller than it is wide, you may overbend the rebar, creating a triangular shape. Vice grips are placed on the underside of the bending jig by a helper as you bend the loop. This is important because the loops will be under tension and spring back out with a lot of force if they are released from the jig. The rebar should extend past the underside of the jig to about 2 inches, or just enough to capture the end using the vice grips. Try to push each piece of rebar through the jig the same amount so that all of ribs are the same once you install and weld the floor bar between them. You could mark each rebar before bending to ensure that each end is placed through the jig at the same amount. The floor bar is the piece of rebar that spans the distance between the lower ends of the rib loop, securing it permanently into the round shape. This bar also determines the overall width of your greenhouse frame and is responsible for holding the lumber that makes raised beds. Once a loop is formed in the bending jig, the floor bar can be positioned for welding as shown here. The easiest way to get a floor bar in the correct position for welding is by adding a few wood screws to the jig to hold it in the proper position. Since the holes drilled in the jig are slightly larger than the rebar, the floor bar sits slightly off the 2x4 as shown here, making a tight joint at each end where it meets the inner side of the rib. Add the wood screws in a position that allows the floor bar to drop into the rib, creating a tight joint at both sides for welding. To ensure all of the completed ribs are all the same shape, I measured the height of the floor bar from the face of the 2x4 jig when it was pushed tight into the hoop as shown here. On my jig, the optimal position of the floor bar was 2 inches above the wooden jig. I marked this distance on all of the following hoops to be welded. As you can see by looking ahead, the small amount of rebar that extends beyond the floor bar is stuck in the ground to help keep the greenhouse secured in place. This anchor may not be necessary in your climate, but we have strong, gusting wind where we live, and I wanted to be sure that the greenhouse would not be pushed around if I decided to use it without the raised beds full of soil. When filled, the raised beds hold the frame down due to their volume weight. With the ends of the floor bar chamfered and prepared for welding, it's just a matter of tack welding them to the inside of the hoops and then completing the weld while they are held by the jig. The number of ribs to weld will be determined by the number of modular segments in your greenhouse. I had 16 ribs to make, as my greenhouse consists of 4 modular segments. Each segment is made from 4 ribs with a 3-foot distance between them, so my total greenhouse length is 48 feet. You can make the greenhouse any length required. It is really only limited by the size of tarp you can find. You can also overlap tarps to make a greenhouse frame that is longer than the maximum length of tarp available. The jig allows for welding the entire joint without having to remove it. To weld the underside of the joint, flip the jig over, rather than trying to weld overhead, which is always a challenge even for a skilled welder. Weld each side completely around the joint, and then let the assembly cool for a few minutes before removing it from the jig. You may need to use a hammer on the jig to remove it from the welded assembly if the holes were a bit snug around the rib. After you do this a few times, the jig will work itself in a bit more as the holes slightly expand. Shown above is one of my completed ribs, 118 inches wide and 92 inches tall. If you plan on adding raised beds to your greenhouse, then there are 2 more small pieces of rebar to add to complete the rib assembly. The raised bed support bars are optional. I made these supports to help the raised bed lumber maintain its overall shape in the wet greenhouse environment. Also, I built the raised beds above the clay soil, which is prone to frost heaving in our cold climate. If you plan on adding the raised bed support bars, then now is the time to determine how wide to make the raised beds. In my design, I wanted to bring a wheelbarrow inside the greenhouse, so I measured the width between the wheels and chose my dimensions based on the minimum amount of walking space between the 2 raised beds. Another thing to consider is, how far can you reach when you are on your knees working the raised beds? I found the measurements shown here to work out very well. We can reach to the back of each bed, 3.5 feet wide, to weed, plant, and harvest. If the raised beds were any wider, it would have been difficult to reach all the way across. Do a few mock-ups on the ground to determine the best bed and walking path widths for your design. The raised bed support bars are 6-inch long pieces of rebar welded to the floor bars in the position of your choice. You will need 2 of these 6-inch pieces for each rib. After cutting, take the grinder to the edges and remove the razor-sharp edges left over from cutting. Since these will be exposed on the inside of the greenhouse, you don't want to cut yourself. Unlike the other T-joints that were already welded, I did not add a chamfer to these bars for welding. The reason is that if I ever want to remove these bars, a good whack with a large hammer will break the welds without damaging the floor bars. Roughly 8 years after building this greenhouse, I did remove these bars, and they broke free with the swing of a sledgehammer, just as expected. We are now using the greenhouse without raised beds. Mark out the position of the 2 raised bed support bars on your floor bar, and then weld them in place as shown here. You can use a square to help set up the 90-degree angle, but like most dimensions in this design, you do not need to achieve perfect accuracy. I welded all the way around the joint, but did not prepare the chamfer. The weld is strong enough to hold the raised bed lumber, but it is also possible to break the weld with the swing of a large hammer. The horizontal joining bars connect the ribs together, placing them at a distance of 3 feet away from each other. This length is not critical. If you find that you can get better usage from the rebar lengths by using a little more or a little less, then go for it. Just ensure that all are the same length. You will require 3 of these horizontal joining bars for every rib, -1. If the greenhouse has 12 ribs like mine, then you will need to cut 33 horizontal joining bars. Looking ahead a bit, you can see why you count all of the ribs and then subtract 1. These new bars are to be prepared properly for welding. Add your chamfer to each end as shown earlier. The recommended position of these horizontal support bars is shown in the next photo. The top horizontal joining bar is placed on the center of the loop, and the 2 lower horizontal joining bars are placed approximately 4 feet from the ground. I chose this position because it's an even distribution of the horizontal joining bars, plus it was a nice height for the drip hose that hung on hooks welded to the 2 lower bars as shown later. Feel free to alter these measurements for your own needs. Mark out one of the ribs using tape around the rebar. You can then use it as a template to mark the rest of them as you continue the build. Horizontal joining bars need to be perpendicular at 90 degrees to the ribs. Use a square and try to get this close. You can easily flex the other end into position, even if it is an inch or 2 off the mark. Once again, close enough is good enough here. Once the horizontal joining bars are completely welded to the first rib, place the second rib on top of the open end and find a way to clamp the bars into position for welding. Tack weld all 3 horizontal joining bars to the new rib and then complete the entire welded joint. At this point, welding has been easy because you are able to move the components into a position that works for you. After this, you will be welding in place since the assembly will be too large to easily manipulate and too tall to weld the third rib without getting on a ladder. Once you are at this stage, stand up the assembly on flat ground so you can continue to add the other 2 ribs to the modular segment. You will likely need to use a ladder to reach that top horizontal support bar, as it will be easier than attempting to roll the assembly on its side to reach the joint. Since I don't have a workshop, all of my builds are done outside. Although it's nice to enjoy a sunny day of DIY, working on uneven ground can present a challenge when attempting to align the segments. To make life easier, I placed a set of 2x12 rails on the ground and then leveled them using a few rocks that were laying around. Using a square, a level, and your keen eye, check the alignment of the ribs from all angles as you continue to add your horizontal support bars. The completed frame will be slightly flexible as well. When you place it on the ground, any inconsistencies will even out. Welding on top of a ladder can be a bit of a challenge, but after several ribs, you will tune up your skills and learn the art of welding in position. Remember, welding spatter falls down from the area being welded. Don't stand directly under the area being welded. One modular section has a total length of 12 feet. Each one includes 3 sets of internal horizontal joining bars and 1 external coupling set to be shown later. Once you complete your first modular segment, you can consider it the front section, and then move on to creating a door frame if you intend to include one. The size of the door is completely up to you. The main consideration is the maximum height you can make it for the given hoop size. I decided to make my doorway 34 inches wide and a maximum 6 feet tall because that is how wide it needs to be to bring the wheelbarrow inside the greenhouse. If you are using a pre-made door, test fit it to see if it will fit into the hoop and then design the door frame as required, adding about a 1/4 inch gap between the door and the rebar. So if your door is 36 inches wide, ensure the space between the door frame is at least 36.5 inches wide. The door frame is a horizontal bar with 2 vertical bars as shown here. Start with a horizontal top bar longer than required. You can trim it to fit the hoop after welding the three pieces together. Once the door frame is welded, place it onto the front hoop as shown here, so you can mark the top bar to be cut based on the size of the hoop. The leftover pieces of rebar will go to making more raised bed support bars. Not much will go to waste in this build. You can also create the front wall completely from wood, including the door frame. Therefore, the rebar door frame is actually optional. With this project, I prefer steel construction wherever possible because it lasts a long time compared to wood panels, which need to be replaced roughly every 5 years in our climate. Measure each side of the door header to center the door frame inside the hoop. Do the same for the door opening on the bottom, maintaining the same door opening width all the way from top to bottom. Once the door frame is centered at the top and bottom, place clamps on both sides of the header to secure them to the frame as shown here. The bottom of the vertical door frame bars rest on top of the floor bar. With the door frame secured and centered, mark a line for cutting. Since the door frame is placed inside the hoop, the line is drawn on the inside as shown here. The door frame should fit nicely in your front hoop as shown in this photo. You do not have to bother with the joint chamfer here, since the door frame will be welded in 4 places into the hoop. It will be very strong with only the basic surface weld bead. Tack weld the door frame and then check one more time that it is centered in the front hoop. Complete the welding of the door frame in all 4 places. The front section is almost completed now. All of the modular segments plug into each other, making this design versatile in several ways. You can add or remove segments as you wish, allowing the greenhouse to shrink or expand as your operation changes. You can easily move them around because each modular segment is light enough to be carried by 2 people. The modular couplings are extremely simple, a 6-inch length of tubing that fits over rebar. One end of the tubing is welded to the rebar to form the female coupling, allowing the other end to easily plug right in. The tubing used to make the coupling only needs to be slightly larger than the diameter of the rebar. You can use anything from fence rail tubing to old cut-up bicycle frame tubing. Shown here is some 1/2-inch electrical conduit tubing that fits nicely over the rebar. Look ahead to understand how the coupling works, and then calculate how many pieces of 6-inch long tubing you will require. If you are making a 4-segment greenhouse like mine, then you will require 9 of these couplings since each modular segment, -1, requires 3 couplings. These are the pieces that will make up one set of male and female couplings for a modular segment. The rebar is cut to half of the length as the other horizontal support bars used to join the ribs together, which makes sense when you consider that one bar butts up against the other. You are simply making a horizontal support bar that is split in half by the coupling tube. On each of these rebar lengths, chamfer one end only, but remove the sharp edges from the other. The coupling tube is welded to one of the coupling bars so that it is halfway inside the tube as shown here. This way, both pieces of rebar end up inside the coupling tube in equal amount. The dimensions shown here have worked very well. Feel free to change them up and try something different. That's what DIY is all about. Once the coupling tubes are welded to 3 of the half-length horizontal joining bars, you will now have a set of 3 female couplers to be installed onto a modular segment. The EMT conduit tubing I used here had an internal diameter that was somewhat larger than the conduit's outer diameter, so I just pounded it flat with a hammer near the joint to make welding a little easier. If you are welding galvanized tubing like this, then be sure to have plenty of ventilation, and do not breathe the fumes as they are toxic. One side of a modular section will have 3 female couplers, and the other side will have 3 mating male couplers. Of course, this does not apply to the front or rear sections, as they only require 1 coupler. Weld the couplers to the modular section just as you did with the full-length horizontal joining bars. In this photo, you can see another length of rebar clamped along the original horizontal bar and the one I am welding. This works like an alignment guide, as well as a place to clamp the coupler for welding to the rib. With the coupler bar clamped in place using the guide bar, check your perpendicular alignment. Now you are ready to weld it to the rib. Keep track of the male and female couplers to ensure that you don't accidentally weld 2 of the same gender onto one section. Weld all 3 matching couplers to the modular section as shown here. Now this female end is ready to plug into the male end of the next modular section when it is completed. Since the modular segments sink into the ground, thanks to the few inches of extending rebar, there is no need for locking between the couplers. They will stay secure by being pushed up together. The modular sections cannot move. Here is the completed front modular section complete with a door frame and a set of 3 female couplers. 2 people can easily move the section around by lifting it by the 2 inner ribs and walking it into place. I have also moved the sections myself by tipping them onto their sides and dragging them along the ground. If you have a long distance to move your sections, then make a simple trailer using a few 12-foot long 2x12 boards with wheels at the end and move them like they're giant wheelbarrows. At this point in the project, you need to duplicate as many segments as you want to make up the entire length. In this photo, I have made 2 more center sections. They are connected to the front door section. The rear section will only require 1 set of couplers if you intend to never add any more sections to your greenhouse, just like the front section has only 1 set. For future expandability, you may want to consider adding the spare couplers so you don't have to weld them on later. If you do add a spare set of rear section couplers, add tennis balls and flagging tape to the ends so that they are not a stabbing or tripping hazard. I have now completed all of the modular sections and have created a 48-foot-long greenhouse frame. I moved the frame to the proposed site. It looks like the ground is very flat and even, something not easy to find on our hilly property. The flatter the ground, the better the tarp will look once it is pulled tight. A slight imperfection in the ground isn't too problematic, but if the ground is really uneven, the tarp will have ugly ripples. If that happens, you will need to level the foundation using whatever method works for you. More soil, gravel, blocks, bricks, etc. Since we will also be potting in the greenhouse, I decided to add a workbench area to the rear section. 2 T-shaped pieces are inserted into the last 2 hoops as shown here, using the same fit, clamp, trim, and weld procedure as used to fit the door frame to the front segment. To make a workbench, I added boards across the horizontal bars. My greenhouse framing is now completed. Before you paint anything, try to consider all of the little things you may want to add to the frame. Hooks are very useful for hanging pots, drip hoses, or lights. Now is the time to add them. To make some hooks, you can purchase a few lengths of 1/4 inch diameter solid rod and bend them into whatever shape you like using a vise and a hammer. The hooks shown here are made from 10-inch long pieces of 1/4 inch rod, bent into a hook shape. I made one I liked and then tried to duplicate the bends in the other 60 that I made. I placed a hook on every rib slightly above the horizontal joining bars so the hooks were centered over the raised beds. The reason for that is so that a drop line could be installed that would drip into the center of the raised beds for even water distribution. This worked out very well. In this position, the hooks are positioned in the center of the raised beds. The next time I have to paint the frame, once every 8 years, I will add another run of hooks about 2 feet above these ones for hanging pots over the raised beds. Extra hanging pots will maximize the amount of vertical growing space in the greenhouse. Congratulations, your framing is now completed. If you are adding a door to the front section, then you still have to weld a set of hinges on, but you can now start painting the rear and center sections. When choosing a paint, a white marine grade paint should be used so that the bars remain cool in the sun. Marine paint is designed to handle a wet environment, and there will be a lot of moisture in your greenhouse. So far, I have found the paint to last nearly as long as the tarp, a surprising 8 years. Even though the tarp was only rated for 5 years, the round design of the greenhouse prevented fraying, usually the main reason why a greenhouse tarp begins to fail. This design has been a huge success out on our farm. To add door hinges, you can purchase a standard exterior set of door hinges and then cut off one side as shown here by the marked lines. The hinges are welded directly to the door frame rebar so that they will never come loose. Cut them to leave roughly a 1/4 inch of metal to weld. The cut-off door hinges are welded to the vertical door frame bars as shown here. As with most standard doors, weld them so that they are near the top and bottom of the door for maximum support. The hinge shown here is on the outside front of the frame since the door needs to open outwards away from the greenhouse. Once all parts have been painted and allowed to cure for at least 2 days, you can begin to move them all into place to their final resting spot. Choose the flattest ground you can find and build up any obvious low spots so that the tarp is snug and free from ripples when pulled over the entire frame. I started with the rear section, but it really doesn't matter which end you place first. At this point, do not stomp the leg sections, 6-inch overhanging rebar, into the ground. You will need to tweak the position of each section to ensure tight coupling before pushing the greenhouse leg stubs into the ground. As you install each section, ensure all 3 couplers butt up against each other so that there are no gaps between the coupling rebar and the female socket. You will need a stepladder to check the top coupler and a helper to do the fine position tuning while you guide the couplers into place. When aligning the sections, take a look down the entire length to ensure that the bottom sections are nicely lined up with each other. There will be some slight variations along the top since the loops will not have all form perfect curves, but it will be minimal. In this photo, the top distortion actually looks worse than it is, probably due to the camera lens. As you can see in the completed photos, the tarp does fit nice and snug on the frame, and it looks fairly straight. The raised bed support bars are a good visual to use for alignment. Here is the completed and painted greenhouse frame set into its permanent home. It looks fairly straight from all angles, and all couplers have a nice snug fit. It is now time to add the tarp. To demonstrate the strength of the 3/4-inch rebar frame, a 170-pound monkey hangs from the top horizontal joining bar. Even with this amount of weight, there is very little noticeable flex in the section. In the 10 years we have been using this greenhouse, not once did I ever have to go outside and deal with the snow piled up on the roof or against the sides. This is not the case with our retail-bought shelters, though, which collapsed after a single wet, heavy snowfall. There is something to be said for quality home-built projects. If you are planning to add raised beds to your greenhouse, then now is the time to do it. Once that tarp is installed, you will be working in the hot zone. Do this work while you still have the open frame. We decided to use 2x12 lumber for our raised beds. It has worked well for most figs that we have grown during nearly 10 years of using the greenhouse. Untreated lumber is recommended since treated lumber is made using chemicals that can leach into your soil. The downside to untreated lumber is that it will only last between 6 and 8 years before it starts to rot from the bottom. Although carpenter ants are a problem in our area, we chose untreated lumber fully aware that at some point the wood will need to be replaced. We could only find 8-foot-long 2x12 lumber, but any length will work since the boards will be fastened directly to the ribs and the support bars. Start by laying out all of the raised bed lumber so you know what has to be cut. It's easy to calculate how much lumber is needed as you are simply making boxes on each side of the greenhouse. I used 24 boards for the raised beds, each one 8 feet long. This photo shows 2 completed horizontal runs for one raised bed. This is where the slope of the ground will really show any imperfections. Looks like I did okay with just one slight hump near the center of the greenhouse. The raised bed lumber can be secured to the rebar using small 6-inch long sections of pipe strapping and deck screws. You will need many of these small segments of pipe strapping. It's best to cut them all ahead of time. I have no idea how many 6-inch pieces I cut, but do know that it was at least one full roll. I also use these strap segments to hold down all of the boards on the workbench. The end board that will complete the raised beds need to be cut to fit inside the hoops. Place an uncut board inside the greenhouse, as shown here, so you can trace a cutting line based on the rebar frame and the mating raised bed board. Since the raised bed boards rest in the inside ribs of the greenhouse, they are angled slightly inward as shown here. Take a marker and draw a line for cutting on the end of the board that was placed used close in the end of the raised bed box, as shown in the last photo. Once cut, you can use nails or screws to fasten it in place to the other boards. You now have an enclosed raised bed that can be filled with soil. Fasten the raised bed lumber to the ribs from the outside as shown here, using 2 pipe strap segments per rib. Install the screws so that the pipe straps are very tight on the rebar. This will prevent boards from being pushed up in the spring when the frost heaves, if that's an issue in your climate. You may want to add a strap to the floor bar section as well to prevent the boards from shifting. Once you have the straps installed, Try to lift the board up. If it moves up the rebar, then the straps are not tight enough. If that happens, move the screws closer so the strap grips the bar tighter. Here is one completed raised bed, secured to the ribs and support bars using many small sections of pipe strapping and deck screws. Although they can't be seen in this photo, I also added pipe straps between the lumber and the floor bars just to make sure that they would not be pushed upwards during spring thaw. This is a problem in our area due to extreme winters, deep frost, and heavy clay soil. With both raised beds completed, it's just a matter of adding the soil and compost mixture. Do this before you install the tarp, as moving many loads of soil into a hot greenhouse isn't fun. It's much easier to dump the soil into the raised bed from the outside than it is to truck it inside and then shovel it out by hand. Working as a team, one person mixed some peat moss and soil into one wheelbarrow, while the other person trucked it over to the greenhouse to fill the raised beds. I am not sure how many wheelbarrow trips this took, but it was certainly a good day of work, as farming often is. Shovel, mix, stir, truck, and dump over and over until the raised beds are full. Having two wheelbarrows working at the same time sure makes the job go a lot quicker. This is the last time you will have the convenience of dumping your soil directly into the raised beds from the outside, so take advantage of it. In this photo, the raised beds were only filled halfway, since we started with the basic soil and then added the peat mixed soil onto the next half. At the time, we didn't have any landscape fabric to put down for weed suppression before filling the beds with soil. Weeds thrive in bare soil. We did plant cover crops, such as white clover, to provide nitrogen in the soil and suppress weeds. We learned that weeds on our rural property are persistent and aggressive. However, green manure crops are extremely beneficial for weed management and soil fertility. The middle walking path was maintained by using a weed trimmer to keep grass and weeds in check. Now that we've seen how quickly grass and weeds grow here, we do use professional-grade landscape fabric on pathways and underneath raised beds. Filling up half of the raised beds took most of the day since the soil had to be moved in a wheelbarrow a few hundred feet for each load. I now use my home-built electric tractor called the Yard Mule to make this work a lot easier. Moving soil was one of the main reasons why I built the Yard Mule, and it is also presented as a DIY project on shopzone.com. The front and rear of the greenhouse need walls installed to maintain heat in the colder months and protect plants from extreme weather. Standard construction-grade OSB sheets were used here. When painted with an exterior paint, they held up well for nearly 7 years. At the end of the tarp's lifespan, the OSB walls started to rot near the bottom. If you don't mind the extra cost, treated plywood would last longer than OSB and save you the extra work of painting it. To make the wall panels, place the 4x8 sheets against the frame and then trace the cut lines from the backside using a marker. The resulting cut-out shapes will be fastened to the frame using zip ties. A jigsaw is all you need to cut out the wall sections once they are traced out. Use a blade with aggressive teeth to allow for cutting at a quick pace. To fasten each of the cut-out wall panels to the rebar, use zip ties placed through holes drilled about ½ inch from the outer edges of the wall panels. Choose UV-rated zip ties, which are usual black in color and rated as such on the label. This photo shows one of the front panels fit into the frame. Of course, it's a perfect fit because I traced the cut lines from the actual greenhouse frame. Trace both sides separately because there may be slight variations in the shape on each side due to the less than perfect bending process. The upper wall sections will have removable vents that can be put back in during the colder months to trap some of the heat. To make nice-looking vents, I traced out a few round objects as shown here. The top section is shown installed with the vent removed. Vents can be installed with hinges and a bit of string so you can open and close them without using a stepladder. Get creative and use whatever scraps you have laying around to make your small moving parts. The front wall sections are now cut and fit into the frame. At this point, I did not add the zip ties because it was much easier to paint the panels on a workbench and then install them into the frame. Since I am using a different color for the walls, I didn't want to splatter paint on my newly painted white frame. This greenhouse may be home-built, but it can also look nice with some extra effort. To blend somewhat into the background, I chose a forest green paint for the wall panels. Any typical exterior house paint will be fine since the OSB will start to degrade far before the paint fails. The next time I build the wall panels, I will use treated plywood and expect that it will last many years if repainted every 5 years. Once the paint cures, you can permanently affix the wall panels to the frame using zip ties, placed about 16 inches apart as shown here. Remember to use UV-rated black zip ties, or the sun will eat them away in a few years. Once you have all the zip ties installed, trim off the excess tails. The fully walled greenhouse is starting to look complete. I also added side vents to the front and a large window to the rear. All of the cutout sections, vents and window, can be replaced to completely seal up the greenhouse in the cold months and over the winter. On very hot windless days, these vents are open to vent excessive hot air. To make a door that will not warp, it needs to be framed with some extra reinforcement. I used the same OSB as the rest of the walls and added a border of 1x2 lumber to help make the door more rigid. The door is something that would be better suited made from treated plywood, but this is what I had on hand, and the growing season was quickly approaching. To ensure the door will fit properly, place the board to be cut up against the door frame and trace it just as you did with the other panels. This will ensure that any tweaking of the frame is translated to the door for an exact fit. To finish the door and give it a barn-style appearance, I added the crossing section of 1x2 boards. The 1x2s are fastened to the OSB using deck screws. The painted door is installed onto the hinges, and of course it fits because it was cut using lines traced from the actual door frame. Of all the parts of the greenhouse, the door is one of the simpler components, but often the thing that people notice first, so I spent some extra time on making it look nice. We had a lot of 3-foot 2x4 pieces left over from a construction project, so we utilized in the workbench top as shown here. 25 2x4s were fastened to the workbench frame using the same 6-inch long pieces of pipe strapping that were cut for the raised bed lumber. 1/2-inch gaps were left between the boards so that water or debris falls through the cracks. Under the workbench, we store gardening containers. The greenhouse tarp will be your largest expense and the most important part of the build. I recommend doing your research on greenhouse coverings to understand the difference between cheap, clear plastic sheet and thick, multi-strand woven poly. A cheap plastic sheet will cost you a few bucks and won't last very long, especially in wind, hail, and snow events. A woven poly tarp will last roughly 5 years in this design. Of course, you get what you pay for. For a 48-foot-long greenhouse like this, you can expect to pay hundreds of dollars for a good quality woven poly tarp. The huge roll of tarp shown here is called 11 mil super strong woven poly. Unrolled, this tarp was 28 feet by 54 feet, which leaves extra to work with once laid over the 24-foot by 48-foot frame. Getting the huge tarp over your greenhouse frame can be a lot of fun, or it can be a source of aggravation. It really depends on what the wind is doing that day and how good you are at predicting its direction. Start by unrolling the entire tarp on the ground so you can be sure it is large enough to cover the frame. We wanted to have at least 2 feet to spare on all the edge to achieve a snug fit all the way around. If there is any wind at all, place the tarp on the side of the greenhouse that the wind is blowing towards. You want the wind to work with you, pushing the tarp against the frame rather than blowing it away. Even a slight breeze can either assist you or defeat you. Find some bricks, rocks, or rebar to weigh down one side of the tarp right up against the entire length of the greenhouse frame, as shown here. Have an equal amount of tarp overhang at the front and back so you don't have to adjust it after it has been pulled over the frame. We live on a hill with a valley out front, so there is no such thing as a non-windy day on our farm. I must admit that it took several attempts to get the tarp over the greenhouse because the wind kept changing direction halfway through the job. Pulling over the tarp is definitely a 2-person job, so of course the tarp promptly fell back down as soon as I stepped away to take this photo. Finally, the wind started working in our favor and pushed the tarp against the frame so it could be worked over the top and then weighted down on the other side. Make sure you have all of your weights ready because once the tarp is covering the frame, it will act like a giant parachute and undo itself in the slightest breeze. After 4 attempts, we finally managed to get the weights all the way around the tarp. You will notice I have just the right amount of tarp overhang on the sides and much more than required on the front. We actually ordered extra length to make small covers for raised beds in the garden. This will be trimmed and used in later projects. You will be working on one side of the greenhouse at a time, So use a lot of extra weights on the side you intend to do last so that the wind doesn't get under the tarp and send it flying into the neighbor's yard. Blocks of peat moss and sandbags did the job quite nicely once I learned that rebar was not enough weight by itself. Get the tarp pulled down as tight as you can, making sure the overhang is equal all the way around. The ends can be tucked into the openings or held in place by leaning 2x4s up against the tarp like wedges. The tarp will be fastened to the greenhouse by screwing 1x2 lumber over the tarp and into the raised beds along the entire length. Cut the 1x2s so that they fit between the ribs. The distance between the ribs on this greenhouse frame is 36 inches, so I cut the 1x2 board to a length of 34 inches. You will need 1x2s to fit between all of the ribs on both sides of the greenhouse. In my case, that was 33 of them. The tarp should be pulled tightly around the frame on the side you intend to start working on. The other side of the tarp should be weighted down heavily so that it doesn't move while you are working. This photo shows one of the 1x2s that will fit between the ribs as well as the deck screws that will be used to fasten it to the raised bed lumber. This is how the 1x2 will fasten the tarp to the raised bed. Screws are placed about 6 inches apart and screwed directly through the tarp into the raised bed sides so that the board clamps the tarp to the raised bedside. When you have one complete length of tarp fastened to the side, move to the other side and repeat the process. This time, though, you want to tug on the tarp to ensure it's tight as you work along the entire length. The tarp should sit snugly to the frame, which will greatly extend its lifespan and make your finished greenhouse look nice. Because of our slightly uneven ground, there were a few slight ripples, but overall the tarp was tight. The imperfections were only noticeable when looking all the way down the length from this angle. From the side view, the tarp appeared to be uniform. The same 1x2 boards are used to fasten the tarp to the end walls as shown here. Cut the boards to conform along the round edges, leaving about an inch of clearance from the outer edge of the panels where they meet the rebar. You can pull the tarp tight on both ends as you work now, since it is securely fastened along the entire side length and won't be yanked out of place. This photo shows the rear end of the greenhouse after installing all of the 1x2s that hold the tarp to the rear wall panels. I could have pulled the tarp to the front quite a bit more to spare some of the overlap, but I still had plenty left over because we ordered a bit longer than needed for the entire length of the greenhouse. Leftover poly can always be used to cover cold frames and make mini greenhouses over raised beds in the garden. Complete the tarp fastening on the other side of the greenhouse using the same method. Once you have the 1x2 installed in the front and back, you can begin trimming away the excess tarp with a pair of scissors. The tarp will be folded over and stapled to 1x2s to protect them the elements and to fully secure the tarp from any further movement. Once all of the 1x2s are holding down the tarp, it should look snug and tight on the inside as shown here. You can slide a finger between the tarp and the rebar without much effort, but there isn't any place where the tarp would be flapping in the breeze, which is what you want for the optimal lifespan. To finish securing the tarp to the frame, roll the excess tarp over the 1x2s and then staple it along the top. This will protect bare wood from the elements and also make it difficult for the tarp to be pulled out of position. Staple the tarp to the top of the 1x2 as shown here, about 4 inches apart along the entire length. This is done around all of the tarp at the front, back, and both sides. Once you have stapled the entire perimeter of the tarp to the 1x2s, you can then trim it away using a pair of scissors. Do not try doing this with a knife, or you probably cut into the tarp underneath and destroy your entire tarp. Cut carefully, making sure you are only cutting the access overhang and not the underlying tarp. The trimmed and stapled tarp looks tight and neat as shown here after finishing the front and rear of the greenhouse. Now you can do the same stapling and trimming along both sides. Here is our greenhouse after completing all of the stapling and trimming. There isn't much left to do now besides planting in the raised beds and waiting for the amazing harvest. To finish the door, gate hardware such as this handle and latch can be added. To be able to unlock your door from the inside, add a string to the latch and then place it through a hole and tie on a washer to the end. This way, you can unlatch the door if the wind blows it closed while you are inside the greenhouse. The life of a gardener includes a lot of weeding and watering, but you can make your work a bit easier by using drip lines and mist hoses. I decided to make my own drip line using standard gardening hose. This method worked okay, but it took several attempts to get the hole size correct. One end of the hose is capped off by adding a male threaded end and a plastic cap as shown here. Holes were drilled along the entire 50-foot length of hose using a 1/8 inch drill bit, placing the holes about 2 inches apart along the painted stripe on the hose. The DIY drip line is shown here, creating a decent mist in the air over the raised beds. This photo shows the greenhouse after nearly 10 years of operation. Everything you see here is all original, including the tarp. Nothing has been repainted. The marine paint is only showing corrosion in a few places, and the wood panels are still functional with a bit of rot at the bottom. I also tried an experimental roll-up side, since we were growing some veggies that preferred a bit less heat in the hot summer months. To make this work, I welded 48 feet of rebar end to end, and then added a handle so that I could crank up the tarp by rolling it up around the long rebar. To make the roll-up system, I welded 48 feet of leftover rebar end to end so that it would span the entire length of the greenhouse. I made a handle using a 2-foot length of rebar and one of the EMT tubes left over from the coupling system as a spinning handle. A washer stops the tube from falling off the handlebar. Here is our completed modular greenhouse in the first year of operation. The thick plants growing in the rear section are tomatoes. They grew vertically up to the very top of the greenhouse. We grew everything from beans to peppers in the greenhouse during nearly 10 years of operation. Almost everything thrived thanks to the extended growing season. Because of the robust design of the frame, this greenhouse will be producing fresh veggies for many more years, requiring a tarp replacement and repainting only once every decade or so. The DIY modular greenhouse has been an excellent companion to our expanding garden, allowing us to get a head start on our short growing season. Tomatoes love the heat and explode in the greenhouse. Because the plants can grow over 6 feet tall, the placement of the horizontal rebar creates a perfect tie point to hold them up. You can also string the plants to the vertical ribs so that they have something to grab onto and climb. To maximize the harvest, we often follow the companion planting method, which places 2 different plants together that naturally complement each other. We have found that cucumbers and squash always become great neighbors when they share a bed in the greenhouse. Peppers of all kinds are another greenhouse favorite, and they thrive in the summer heat. Like most plants that are lucky enough to get a bed in the luxury of the greenhouse, they do much better than their neighbors out in the open garden. Pest and weed management is also somewhat easier in this controlled environment. Our heavy winter snow is not an issue for this extremely strong greenhouse design. Most snow falls from the top due to the egg-shaped hoops, but in the event of a heavy wet snow, this frame can handle loads without any problems. For nearly 10 years, I have never cleared snow from the roof. Every year, I look forward to planting a new harvest in our DIY greenhouse to see what we can grow. We are often surprised how well this simple design works for our fresh produce needs. We grow a variety of crops in this greenhouse: tomatoes, peppers, eggplant, rosemary, basil, lavender, cucumbers, and squash. We hope you enjoy your DIY modular greenhouse. Please stop by our Builders Forum at chopzone.com sometime and show us your work as it progresses. We love seeing what others are building. There is an amazing community of friendly DIY enthusiasts, just like you, to share ideas, tips, and tricks. Our work is made possible by the DIY community. We appreciate your support. Good luck with your build and happy growing.